This is a video for exam 1, number 7. In number 7 it says, suppose that f of x is equal to this piecewise defined function x squared minus 1 when x is less than or equal to 1, and k times the quantity x minus 1 whenever x is greater than 1. This is the function that the problem gives us, and it asks for what values of k is this function f differentiable at x equals 1. Take a second to read the question carefully and think about what important words might help to decide what we're trying to do here. The most common mistake on this problem was to think that we were asking for the value of k that would make this function f continuous at x equals 1. It's a bit of a mistake, because this problem is actually asking us for something a little different. It's asking us to look for what values of k is going to make sure that f is differentiable at x equals 1. So you are expected to know, what does it mean for a function to be differentiable? Well, a function is differentiable whenever this is true, okay? We say a function f is differentiable at, say, x equals a if the limit as x approaches a of the derivative of f of x exists. This is what it means to be differentiable. And so to solve this problem, we don't so much need to know about f, we need to find out about the derivative of f. So let's find the derivative of f of x. Let's see. The derivative of f of x here is going to be another piecewise defined function. Let's find the derivative of this first rule. The derivative of x squared minus 1 is 2x, and this is true whenever x is less than or equal to 1. And how about the derivative of k, which is a constant, times the quantity x minus 1? Well, it's just a constant times this quantity. The derivative of x minus 1 is just 1, so really the derivative of k times the quantity x minus 1 is just k. And this is true whenever x is greater than 1. Okay, so now when will this limit exist? Well, the limit, for this limit to exist, it needs to have the same left-sided limit as it has right-sided limit. In other words, the limit has to be the same as we approach f of x, the derivative of f of x for values that are less than 1, and also for values that are greater than 1. Well, certainly the limit of a constant function is going to be that value itself, so what we can do is, right here at x equals 1, we can set these equal to each other. So we'll say 2 times 1 has to equal k, which means that 2 equals k. If you like to write it k equals 2, that's fine.